everyone, welcome to my channel. I'm Thiago, and today we're starting a series of videos in which we are going to dive into some of the most exciting algorithms and computer science challenges that I can find on the internet. A little bit about myself first. I have a Bachelor of Computer Science by the Universidade Federal de São João del Rei and a Master of Computer Science by Tsinghua University in China. I currently work as a data scientist, specializing in natural language processing and machine learning. Now you might be thinking, why am I doing this series on algorithms and computer science? Well, algorithm problems are very interesting to solve because they often show up in coding interviews, competitions, and they are a fantastic way to sharpen your programming skills. To kick things off, we are starting with Project Euler. We are not limiting ourselves just to Project Euler, but we're starting with this website. Project Euler is a collection of mathematical and computational problems that challenge you to think critically, write efficient code, sometimes learn new mathematical concepts. And I've actually have solved many problems there before. But what makes Project Euler so special for this series of videos? First, it's a great way to improve your problem-solving skills. The challenges in that website are crafted efficiently, and there are lots of edge cases. You need to think very well, very deeply about the algorithms you write to pass in the projects. Second, it's perfect for learning new techniques, especially mathematics, algorithms, data structures. You will encounter problems that involve everything from number theory to combinatorics to optimization, cryptography. And third, the problems start very simple, but they get hard very, very quickly. So this is very challenging. I like it. And let's see how far we can go into their list of problems. In this series of videos, I'm resetting my progress so we can go through these challenges together. And let's see how far we can go into that. I'll be solving the problems there step by step with you, sharing insights along the way. All the solutions that I write will be available in my GitHub page. You can find the link in the description down below to my GitHub page. So let's first reset my problems on Project Euler. By the way, my account here on Project Euler is called Thiago Souza. And 31194. Reset progress. Okay, now it goes. So yeah, now I have no progress here. So just an additional thing, in this series, I'll be using Python as programming language to solve all of these problems. Why Python? Well, because it's the language that I like the most, is the language that I use the most. I use it in my work. And I think it's a quite simple and easy to learn language for those who are interested about learning about algorithms, data structures, a little bit of data science. This language is very useful for that purpose. I like to use the PyCharm IDE, which is this IDE here. It's a personal choice. Like you can check on the whole environment set up on my GitHub page, but feel free to use whatever IDE that you want. Okay, so with that in mind, let's jump into the first problem on Project Euler. The name of the problem is multiples of 3 or 5. If we list all the natural numbers below 10 that are multiples of 3 or 5, we get 3, 5, 6, and 9. The sum of these multiples is 23. Find the sum of all the multiples of 3 or 5 below 1,000. First of all, why these numbers are multiple? I guess that's quite clear. 3, 6, and 9 are multiples of 3. 5 is a multiple of 5. If you sum all of this, it's 23. We need to do the same thing about all the numbers below 1,000. So there are two basic solutions to this problem. The first one is a solution that we can do by an algorithm, a code. The other solution is like we don't need actually that. We can just use pen and a pencil, like a paper, to do that, or just a calculator. Let's do both of the solutions, starting with the coding. So let's go to the IDE. Now I'll create a new directory, and I'll call it problem 1. And within here, I'm going to create a new Python file called problem1.py. Right, adding it. And as I said, this problem is very simple. We can just loop over the numbers up to 1,000 in Python. So here with this for loop, I'm going through every single number in there. Then we're going to check if this number is a multiple of 3 or a multiple of 5. To do that, we can just see the remainder of the division of this number by 3 or by 5. The remainder will tell us if the number is divisible, therefore it's a multiple. We can just do this in Python with the following syntax. If the remainder of the division by 3 is equal to 0, or if the remainder of the division by 5 is equal to 0, then we can just sum this number. Let's just create a variable to sum this number. The name of my variable is s, right? So we have to initialize this variable with some value, which is 0. We don't know the number yet. Then we can just loop over the entire list of numbers, sum it up, and then we have the result. We need to print this result so that we can see it. So let's just print this result. And that should be about it. Let's check running this code to see what number that we get here, what result that we get. So we can just do Python and then problem1, problem1.py. And let's just go for it. And this is the result we get. Let's just copy the solution. Okay. Yes, congratulations. The answer you gave to problem 1 is correct. So as I said, there is a mathematical solution to this problem, and I think we can also explore it a little bit. We don't need actually code to do it. We can just do with a pen and a paper and or just a calculator, or we can do it here in the interface just to show to you guys. So let's go mathematical solution. I don't know how to call it. Let's call it mathematical solution. Well, the solution would be very simple, is that we just need to know the sequences of numbers that are multiples of 3 and 5 below 1000. What do I mean by that? So what are the numbers that are multiples of 3, right? So it's just the numbers that are divisible by 3. So 3, 6, 9, 12, 15, and so on, right? And there is also the multiples of 5, which is also a sequence. 5, 10, 15, 20, so on, right? So as you can see, the multiples of 3 are like, you have a step by 3 here in this sequence, and the multiples of 5, you also have the step by 5. If you know all of these numbers, you can just sum them up. There are some repetitions that we have to subtract. So for example, 15 appears twice here, so we also need to remove those numbers. We can even write it here, multiple of 15. We can 15, 30, 45. We can remove those numbers from the calculation if we do it twice, right? But if we know the sequences, we can just sum the sequences, and then we have the result. How to sum a sequence? There is a formulation for that. The sum of a sequence of numbers is given by the first number of this sequence, let's call it A1, plus the last number of this sequence, let's call it AN, multiplied by this whole thing multiplied by the number of numbers in this sequence, divided by 2. So we divide this whole thing by 2. This is actually the formulation for the sum of a sequence, right? We can do this for the multiples of 3, 5, and 15, and then we have our final result, right? So let's just try to do it here so that we can show, right? So the sum of this sequence is actually the sum of the multiples of 3 are then like the first number of this sequence that is a multiple of 3 is 3. The last one below 1000 that is divisible by 3 is 1000 is not divisible by 3, but 999 is divisible by 3. So this is the last number of this sequence within the range of the problem, right? Then we have to multiply how many numbers are there in this sequence from 3 to 999. How can we know that? Well, we know the total number of numbers, which is 1000. We can divide that by 3, which is the number that we have here. Then the last part of our calculation is to divide by 2. And there you have it. We have like the sum of all the numbers divided by 3, multiples of 3, right? We can do the same thing for 5, right? So the first number of the sequence of 5 is 5. The last one in this sequence would not be 1000 because 1000 is out of the scope according to the problem, right? So it would be 995. Again, like we have to multiply this by the total number of numbers in this sequence. We just divide by 5, and then we divide this by 2. And again, like some numbers will be repeated if we sum them twice, right? So for example, 15 is a multiple of both 3 and 5. We have to subtract those. We can do that as well. So the first one would be 15 plus the last number below 1000 that is divisible by 15 is 990. And then we multiply this by the number of numbers below 1000 that is divisible by 15, divide by 15 here, and we divide this by 2, right? So let's just print the two solutions then, right? So that we can compare them to see if they are right. And as you can see, this is the first solution of here, so that we can use as a comparison. But the second one is not really right. It's actually bigger, right? And you can see here that there is a floating point on it. The reason is that there are two reasons for this. The first is that this division here is not exact, right? So actually we have to get the integer part of these divisions. We cannot get the continuous part, just the discrete one. So we just put int here to force it to give us a natural number, like a discrete number instead of a continuous number. If we do this, then we're gonna have a different number. And this doesn't seem very right. It still seems a bit wrong. Probably because of dividing 1000 by 5, since 1000 itself is a number divisible by 5, we have one number more. We need to remove one from this calculation here. Then we should have it about right. Yes, we have it about right. We still have a floating point here, which don't care, right? Let's just add an int to the entire thing so that we have a number. And there we have it. We have the same problem solved on the two different solutions, right? I guess this was straightforward. I'm gonna push this code later to my GitHub. I'm probably gonna add a simple explanation of everything I said into a documentation here so that you guys can see that. This is a solution to problem number 1 of Project Euler. Very, very simple. I hope you guys enjoyed it. If you liked it, please subscribe to the channel if you want to see more. Like hit on the notification for when I post new problems. And I see you in the next video.